You might recall in the last video that we used a power series to solve this differential, y prime minus 2y is equal to 0. And the solution that we got was this power series. Alright, so I'm going to erase some of the stuff that's going on around here. Alright, so this was the power series that we got. And what we'd like to do, we didn't get to do this in the last video, but we wanted to find the initial value for this. Alright, so and that's actually pretty easy, because what you're going to do is you're just going to write out a few of the terms. So y is going to be equal to, so all we're going to do is we're going to plug in n equals 0, n equal 1, n equal 2, n equal 3, etc. just to see what that looks like. So that becomes c0, 2x to the 0 over 0 fact, plus, so now we're going to plug in 1 for the n's, so c0, 2x to the first divided by 1 fact, plus c0, 2x square over 2 fact, plus c0, 2x cubed over 3 fact, etc. Now remember the initial condition that we had, y at 0 is equal to 1. So all we're going to do is just substitute 0 back in for each of the x's. Now we can simplify this, by the way. So y equals, this just becomes c0 plus c0 times 2x plus c0 times 2x square plus, so this is going to be 8/6, so that's going to be 4/3 c0 x cubed, etc. Right. Now what happens when we substitute the initial value? Well, we get 1 equals c0 plus c0 times 2 times 0 plus c0 times 2 times 0 square plus 4/3 c0, 0 cubed, etc. And notice it looks like every single term that's going to have an x afterwards is just going to cancel out. So we just get that 1 is equal to c0. And so our solution, we can just replace the c0 with 1, and the solution to the initial value is just going to be 1 times all that stuff. Or another way to write that is just to write that as, give me 1 second, after erasing all this, that's just going to be equal to our series n equals 0 to infinity, 2x to the n over n fact, which is the same thing as e to the 2x. And you might recall on the first video when we solved it analytically without the series, you might recall we went all the way, let's go all the way back up. And remember we solved it analytically, we got y equals e to the 2x. And so that was the initial value. So this was just to illustrate how to go through and solve an initial value problem using the series. Just write out maybe the first few terms, and usually if it's a really nice sort of problem like the one I just gave you, then it's going to simplify really nicely. Now if I gave you y at 1 is equal to 1 or something like that, then it might be a little more difficult, because obviously not all the terms are going to cancel out. Alright, so that might be a little bit more problematic. But I'm going to try to keep them really easy for the initial values for everybody.